Hello students, welcome to the online lecture series of Sri Chhatrapati Shivaji Maharaj College of Engineering Medhi, Ahmednagar. Today we will discuss about microprocessor and our topic is interrupt and exception. So first of all, what is interrupt and what is exception? Interrupt is nothing but a signal from external device or from another program which cause halt or which stop your program temporarily. An exception is nothing but while execution of your instruction or your program, a special condition is occurred which cause exception. For example, when instruction is trying to fetch the page which is not available, at that time the exception is occurred. The next, interrupt. There are two types of interrupts are available. First is hardware interrupt and second one is a software interrupt. Hardware interrupt again categorized into maskable and non-maskable interrupt. The maskable interrupt is one that you can ignore, such as a INTR pin, and non-maskable interrupts are those that processor cannot be ignored. Those types of except interrupts must be serviced by the processor, such as a NMI, non-maskable interrupts, and software interrupts. There are 256 software interrupts are available. Okay, so next is identifying interrupts. How processor is identify the interrupts. So for again non-maskable and maskable interrupts, there are two different identifiers. With the help of these unique identifiers, processor identifies non-maskable and maskable interrupts. For maskable interrupts, the with the help of external interrupt controller such as Intel's 8259A programmable interrupt control, processor is identifying the interrupts. So this is a table which shows the identifier. These are the unique identifiers which describes the particular interrupts. For example, for identifier 0, there is a divide error interrupt occur. Means when the interrupt 0 is occur, when interrupt 0 is occur, it must identify as a divide by 0 error. And for software interrupt, it uses 32 to 255 numbers for identifying the software interrupts with the help of INTR pin. Then next is enabling and disabling interrupt. How microprocessor enables and disables the interrupts and when. To enable and disable the interrupts, microprocessor must service the interrupt and exception occur between one instruction is executed and another one in line. Means when the microprocessor enables or disables the interrupt, when the instructions is executed, the microprocessor must have to wait to complete that instruction. And when the next instruction is begin, the in middle between time, the microprocessor process or service the interrupts. So microprocessor does not affect the execution of current instruction. It must have to wait to complete the current instructions. And what will happen at the repeat instruction scenario? Means the string instructions. String instructions uses repetitions of instructions. So at that time, what happened? The when one instruction of repetition of string is completed, at that time processor service or execute the interrupt and again the repetition is come back. The next one is a priority among interrupts. how to decide the priorities. Uh, it must happen at some situation or at some point when one or more than one interrupts are occur. So how to handle this situation? So at that time, processor must have to take care of the priorities of the interrupts. So there are two priorities, highest and lowest. So processor must have to first service the highest priorities of interrupts, and after completion of that highest priority of interrupts, then processor goes to the lowest priority of interrupts for servicing. So these are some highest priority of interrupts: faults, except debug faults, trap instructions such as INT0, INTN, INT3, debug trap for the instructions, debug fault for next instructions, NMI, that is non-maskable interrupt instruction. These are the highest priority of instructions that must be serviced before the lowest priority of interrupts, that is INTR pings. Then next topic is interrupt descriptor table. Interrupt descriptor table, as we seen in our previous lectures, what is interrupt descriptor table? It describes the 255 interrupts, or it contains the 256 interrupts that total interrupts are. So IDT, how IDT identify that particular interrupt? For that, IDT uses the IDTR registers. IDTR registers that contain the IDT base, the base address of your IDT table, that is interrupt descriptor table, and the limit of your IDT descriptor table. So in this way, your interrupt descriptor table is work. The IDT descriptor table contains task gate, interrupt gate, and trap gate. The interrupt procedure. IDT descriptor may contain interrupt gate or task gate or trap gate. But for interrupt procedure, the interrupt gate or trap gate indirectly points to the interrupt procedure. As shown in this figure, with the help of interrupt ID, we will get trap gate or interrupt gate from IDT, that is interrupt descriptor table, which again points to the executable segment descriptor in either GDT or LDT. An offset field will point to the entry point of service routine, which will service the current occurred interrupt. Means in this way, the interrupt procedure is takes place. Then next is the interrupt task. How interrupt task is used to execute the current interrupt. When 80386 uses interrupt task, it automatically starts two schedulers. One for operating system, which is a software scheduler, and another is hardware scheduler, that is actual interrupt mechanism. Task gate is used to point to task that is used in servicing the interrupt.